A micro SD card is shipped with the RAK831 Pilot Gateway with all software pre-installed, as mentioned in tutorial 28. In this tutorial, I will show you how to install all the required software on a micro SD card yourself. The result is a bootable micro SD card which can be used in the RAK831 Pilot Gateway. First, download Raspbian Lite. Lite is a minimal version of the Raspbian image for the Raspberry Pi. The Lite version has only a command line interface and no desktop or GUI of any kind. This means fewer modules will load with the kernel, thus less of the Raspberry Pi's resources are used. Go to the Raspberry Pi website, select Downloads, select Raspbian, and download the Lite version, in this case the Raspbian Stretch Lite. After the Raspbian Lite is downloaded, verify the SHA-256 checksum. The checksum is a hash number and is used to verify the integrity of the file. On Mac OS, enter this command. On Linux, enter this command. And on Windows 10, enter this command. After the file is downloaded, open a terminal and let's check the checksum. Enter this command. This checksum matches this checksum value. This means this file is not corrupted or changed during the download. We need a micro SD card. A size of 8 GB will suffice, but in this tutorial I will use one with 32 GB. My MacBook has an SD card slot, so I will be using this micro SD card adapter. Next, download and install Etcher. Etcher is a tool for Windows, Mac and Linux for flashing images to SD cards and USB drives. Go to the balena.io website. Please note, resin.io is now called Balena. Select More Products and select Balena Etcher. Download this application. After this application is downloaded, install it. Now I will demonstrate how to flash the Raspbian Lite onto the micro SD card using Etcher. Open the Etcher application, press button Select Image, select the Raspbian Lite zip file, check if the micro SD card is selected. This is correct. And then press the Flash button. After the flash is complete, you can close the application. If you don't see your micro SD card, remove your micro SD card and insert it back again. The micro SD card has a boot partition. On Mac OS, c/volumes/boot. Go to the boot partition and add an empty file with name SSH. When the Raspberry Pi is rebooted, it will look for file SSH. When found, it will enable SSH. By default, SSH is disabled. After the reboot, the SSH file will be deleted. Select Boot. This will open the boot partition. The boot partition contains these files. Open a terminal and go to this boot partition. Create a file named SSH with no extension. Enter this command and press Enter. As you can see, the file is created. Eject the micro SD card and remove the micro SD card from your computer. Insert the micro SD card into the Raspberry Pi. Connect the LoRa antenna to the gateway. Never power up the gateway without the LoRa antenna. Otherwise, this can cause damage to your gateway. It is not required to connect the GPS antenna because GPS is by default disabled, as explained in tutorial 28. Connect the gateway to a router using an Ethernet cable, as you can see over here. Power up the gateway using the included power adapter. Do not use a power adapter with less than 2 ampere output. By default, the Raspberry Pi has the hostname Raspberry Pi. There are several methods to get the gateway IP address. I will only demonstrate 3. The first method uses the router devices list. Open a browser and navigate to your router's IP address. The IP address is usually printed on a label on your router or check your router's manual. To access your router's configuration interface, you need its username and password. Check your router's manual. Locate the gateway. The gateway name is Raspberry Pi, and write down its IP address. I have opened a browser and entered my router's IP address. This IP address may differ in your situation. In the router's configuration, locate the Raspberry Pi gateway and find its IP address. For example, this is my gateway IP address. The second method to get the gateway IP address is resolving the hostname.local with multicast DNS. On Raspbian, multicast DNS is supported out of the box by the Avahi service. If your computer supports multicast DNS, you can reach your gateway by using its hostname and the .local suffix. Open a terminal and enter command ping raspberrypi.local, and you will see the gateway IP address. If your computer does not support multicast DNS, install the Net Analyzer app, which is available for iOS and Android on your mobile. Select the ping option and enter raspberrypi.local, and you will see the gateway IP address. If both methods does not work, try method 3. Connect a monitor using an HDMI cable and connect a USB keyboard to your gateway. On the monitor, you will see the login prompt. The default username is Pi and the password is Raspberry. Log in with above-mentioned credentials. Enter command hostname-i and the IP address will be shown. On Linux and Mac, the SSH command can be used to access the Raspberry Pi. On Windows 10, SSH can be used or instead use PuTTY. To enable SSH functionality on the Windows 10 PowerShell, open Settings, view the apps, go to the Manage Optional Features, click Add a Feature, select Open SSH Client, wait and then reboot. Unfortunately, I cannot demonstrate this because I do not own a Windows 10 computer. Now let's access the Raspberry Pi. Enter this command. Pi is the default username. And this is my gateway IP address. Press enter. Are you sure you want to continue connecting? Answer with yes. And enter the default password Raspberry. As you can see, Wi-Fi is disabled. Let's check the current time. This is not correct. I am in a different time zone, so I will change this later. Let's check the disk space. Enter this command. This is correct. My micro SD card is 32 gigabytes. This means I do not need to expand the file system on my micro SD card. Enter this command to check if SPI is enabled. This means SPI is not enabled. I will change this in a moment. SPI must be enabled because communication between the Raspberry Pi and the RAK831 concentrator goes through these SPI buses. The Raspberry Pi needs to be configured. I will change user Pi default password, the time zone, and enable SPI. Open the Raspberry Pi software configuration tool. Enter this command. First, change user Pi default password. Select the first option. Press the enter key and enter a new password and retype the password. The password is now changed successfully. Press the enter key. Now let's change the time zone. Select localization options. Select Change Time Zone. I live in the Netherlands. I select Europe. And I select Amsterdam. Now I will enable SPI. Select Interfacing Options. Select SPI. Would you like the SPI interface to be enabled? Use your cursor keys and select Yes, and press the Enter key. The SPI interface is now enabled. Press the Enter key. You can also change your language and your regional settings to match your location, but in this tutorial I will not change my language and regional settings. Press the right cursor key and select Finish. Press Enter. Now reboot the Raspberry Pi, enter this command and press Enter. After a few minutes, access the Raspberry Pi, enter the SSH command, enter your new password. Let's check the time zone. In my case, the time zone is correct. And enter this command to check if SPI is enabled. As you can see, SPI is now enabled. Now I will install all relevant software. First, upgrade the Raspberry Pi packages. Enter this command. I have entered the command. The Raspberry Pi packages are now upgraded. Next, install Git. Git is a distributed version control system. Enter this command. I have entered the command. Do you want to continue? Git is now installed. I have forked this repository and simplified the installation procedure. So this is the new repository, which contains just a few files. The install script creates the gateway AUI, allows the user to set the gateway hostname, allows the user to select the region the gateway will operate in. Dependent on the selected region, the correct global configuration file is copied from the configurations files folder. The local configuration file is copied from the configuration files folder and the gateway AUI is set in this file. Allows the user to set the gateway latitude and longitude coordinates and its altitude. Installs the Semtech LoRa library and the Semtech UDP packet forwarder and builds both packages. Makes the packet forwarder a service, which means when the Raspberry Pi boots, the packet forwarder is started, and disables the onboard Raspberry Pi Bluetooth. This is my repository, which has been forked from the RAK Wireless repository. I have added this configuration files folder and modified the install script. Open the configuration files folder. These files were copied from this repository. And I have made modifications to these global configuration files, as mentioned over here. Before you start with the installation procedure, you must know which frequency plan to use in your country. See the list of frequency plans by country list. This is the web page. For example, select the Netherlands. Here it is, the Netherlands. And this is the frequency plan we have to use. If you are curious, the frequency plans can be found at this location. So this is the web page. And as you can see over here, here are all the frequency plans. So the Netherlands uses this frequency plan, as you can see over here. And here you can see the frequencies the gateway should be using. If you know the frequency plan, look at the table and find the corresponding region. So in my example, the frequency plan was this, so the region is EU. Now let's begin with the installation procedure. Log in into the Raspberry Pi. This is the Pi's home directory. Enter this command to clone the repository. And as you can see, the repository is cloned. Go to the repository. Enter this command to execute the install script. This is my gateway AUI. The gateway AUI is needed when you register the gateway in the Things Network console. So write it down. The installer asks for a hostname. I will keep the default hostname. Press the Enter key. The installer asks for a region. The default region is AU. I press the Enter key. It asks for a latitude in degrees. I keep the default. Press the Enter key. It asks for a longitude in degrees. I will keep the default. I press the Enter key. It asks for the altitude in meters. I will keep the default value. I press the Enter key. And now the system will reboot in 5 seconds. By the way, I have kept the default hostname, latitude, longitude, and altitude. The latitude, longitude, and altitude will be set later in the Things Network console. I will log into the Raspberry Pi. Go to this folder and go to the TTN Gateway folder. As mentioned earlier, the install script installs these two packages. This is the Semtech LoRa library version 5.0.1. And this is the Semtech UDP packet forwarder version 4.0.1. The LoRa gateway packet source is this repository. And the packet forwarder source is this GitHub repository. Let's check the TTN Gateway server status. Enter this command. As you can see, the gateway is active and running, and there are no errors. As you can see, GPS is disabled. If you want to see more logging, go to this folder and open this file. And here you can see more logging. The RAK831 Pilot Gateway can be connected to any LoRa network servers. In this tutorial, the RAK831 Pilot Gateway will be connected to the Things Network server. The Semtech packet forwarder is configured via a file called globalconfiguration.json and, if provided, an additional file called localconfiguration.json. The global configuration JSON file is the main configuration file and contains, for example, the LoRa network server address, which uplink and downlink ports to use, which frequency to use, and the transmission power lookup table. The local configuration.json file contains more gateway-specific parameters. The local configuration.json file will override the settings in the global configuration.json file. The install script creates the global configuration.json and local configuration.json files in this folder. Several other global configuration.json file examples can be found in this folder, but these files are not used. As mentioned earlier, this README file explains where the global configuration files originates from and what modifications were made to these files. In tutorial 28 is explained which parameters to set in the local configuration.json file to enable GPS and for beaconing. In the local configuration.json file, these parameters are commented out. Uncomment these parameters if needed. Go to this folder. Here is the global configuration.json file, and here is the local configuration.json file. Open the local configuration.json file. As you can see, here is my gateway ID, and the gateway ID is used to register the gateway in the Things Network console. The GPS configuration is commented out. If you want to enable GPS, remove these comments and make sure you add a comma here to create a valid JSON file. As you can see over here, the beaconing parameters are also commented out. To use these beaconing parameters, remove this comment and this comment. In tutorial 30, you can find an explanation of all the parameters used in the global configuration.json and local configuration.json files. When the global configuration.json or local configuration.json file is changed, always restart the gateway. Before restarting the gateway, optionally empty the syslog file. Enter this command, followed by this command, and enter the command exit. To restart the TTN gateway servers, enter this command. Instead of restarting, you can stop it by entering the command sudo service ttn gateway stop, or to start it, enter the command sudo service ttn gateway start. As mentioned earlier, to check the TTN gateway server status, enter this command. And to check the system log for errors, you can enter this command. So the gateway is now running without errors. What are the next steps? Register the gateway to the Things network, watch tutorial 28, open this link, and optionally enable Wi-Fi. Again, watch tutorial 28, open this link. Thanks for watching. I hope you enjoyed the video. Please hit the like button and don't forget to subscribe. If you have questions, leave your comments below. I'll do my best to answer them.